This is Edexcel Pure Maths 2, IAL Accounting Exercise 2.4, Tangent and Chord Property. Okay, if you see this over here, I have the circle, correct?
Yeah.
This is the center of the circle. Center of the circle, if it is origin, the coordinates of the center is going to be 0, 0. And if it is not origin, then the coordinates of the center is AB. Are you with me?
Yes.
I have a tangent, and you see that the radius is meeting the tangent at a point of contact.
Yeah.
Okay, the point of contact of the radius and tangent, the angle that it makes is always a 90-degree. Okay, the angle that the radius and the tangent make is always 90-degree, and that is why we say that the radius is perpendicular to the tangent. This is the property. What is the property?
The radius is perpendicular to the tangent. Tangent.
Radius is perpendicular to the tangent. Are you with me?
Yeah.
Now, if I have a circle, say this is a chord. Are you with me?
Yes.
This is the center of the circle. Are you with me?
Yeah.
Tell me which line would bisect the chord. Can a
If you
line
draw the
from
line
here bisect
downwards.
the chord?
No.
Can a line from here bisect the chord?
No.
Can a line from here bisect the chord?
Yes.
And if I have a line, that means it goes infinite.
Yeah.
So can I say a diameter can be the perpendicular bisector of the chord?
Yes.
So diameter is a perpendicular bisector of the chord. If it is a perpendicular bisector of the chord, what could be the relationship between the diameter and the chord?
Diameter and the chord. It's going to be perpendicular.
Perpendicular bisector 90, I understood, but
Yeah.
what would be the relationship between it?
I have no idea.
The gradient of the chord and the gradient of the perpendicular bisector, the product of it would be gradient of the chord multiplied by the gradient of the perpendicular bisector.
Is it going to be -1?
It was going to be -1. Okay. Similarly, the relationship between the radius and the tangent, their gradient's product is going to be how much?
-1.
-1. Now, whenever you have any sums related to the circle, it is always advisable that you draw a diagram and then solve. Okay. I have a circle who has this equation. Can you see this?
Yes.
If it has this equation, what can you derive? Can you tell me?
That the center point is going to be 2. The x
Hmm.
coordinate is going to be 2 and the y coordinate is going to be 6.
That means the center is 2, 6. What
Yeah.
else?
That the radius is going to be 50. I mean 100 squared.
What
100
is going
square
to be
meter.
the radius?
10.
Okay. The radius is going to be 10. Very good. What have they told me?
Verified at the
Ask
point.
me.
Yeah.
Yeah, tell, read.
Verified at the point P 10 0 lies on C.
Okay. So I want to verify that P lies on C. P lies on C, that means P can be anywhere on the circle.
Yeah.
I put this point P over here and I say the coordinates of point P is 10, 0.
Hmm.
How can you verify that the coordinate of that point P lies on the circle? What can
I
you
think we
show?
need to plug this value into the circle equation. And if it's equal to 0, then it's on the circle.
What is equal to 0, then it will be on the circle?
If we plug in the value of P into the equation of the circle, and if it's equal to 0, then it could be on the circle.
Okay. So if the point P coordinates, I put it in the equation of the circle. If it satisfies the equation of the circle, this is the equation of the circle, right?
Yeah, okay.
If after plugging the coordinates of point P into this equation, I get the left hand side equal to the right hand side, that means I'm going to put the x and y over here. If
Yes.
it satisfies the equation, then point P would be on the circle. Okay. Say it's satisfied, and now I say point P is on the circle. Now, what do they want me to find?
Find an equation of the tangent to C at point 10, 0, giving your answer in the form ax plus by plus c equals 0.
Okay. So P is on the circle. I want to
Yeah.
find the equation of tangent to C. Means what?
The point which touches the C at 10,
C
0.
is the circle, okay?
Yeah.
So I want to find the equation of this line. Yeah?
Okay. Yeah.
It's
So
touching the
it's,
circle at P.
yeah.
So I want to find the equation of the tangent.
Yeah.
And what would be the equation of the tangent?
Y is equal to mx plus c. The
Okay.
gradient is going to be 0
Gradient of what?
of the tangent.
Anything else good that you could think of? I have the center.
Yeah.
I have the point P.
Hmm.
Okay. This is my tangent. I want to find
Yeah.
the equation of the tangent. How will I find? Can I first find the gradient of the radius?
Okay.
Can I find the gradient of radius?
Yeah.
How?
Change in y divided by change in
This is
x.
x1, y1. This is x2, y2.
Yeah.
So y2 minus y1 over x2 minus x1.
Yeah.
Say I got my gradient of the radius as minus 3 comma 4. Now,
Okay.
now
Now,
I got my gradient of the radius, right? Do I say
yeah.
gradient of radius? So what will be the gradient of the tangent?
So it's going to be minus 3 by 4 multiplied by something which gives us minus 1. So
So
in
I
this
would say
case,
gradient of
it's going to
radius
be,
into gradient of the
yeah,
tangent is equal to minus 1. So
yeah.
minus
So
3
4
by
by 3.
gradient of tangent is equal to minus 1. So gradient of the tangent is 4 by 3. Or I would say the reciprocal into minus.
Yeah.
Yeah, are you sure?
Yes.
Okay. So the gradient of the tangent is going to be 4 by 3 because radius is perpendicular to the tangent. Yeah,
Yes.
radius is perpendicular to the tangent. So gradient of the radius multiplied by in the gradient of the tangent, you're going to get minus 1.
Yeah.
Okay, so I got the gradient of the tangent 4 by 3. What do I want? I want equation of the
Equation
tangent.
of the tangents
To get
to
the
see how.
equation of the tangent, and now I have the gradient of the tangent.
Yeah.
Okay, I have the gradient of the tangent. I know the point at which it is intersecting is 10, 0. So I will use the formula, always I will use the formula of slope point form.
Okay.
Slope point form equation is y minus y1 is equal to mx minus x1. M I have y will be as it is, x will be as it is, x1 will be 10 and y1 will be 0 because the point on the tangent is 10, 0. So the y1 will be 0 and x1 will be 10.
Yeah.
Are you with me?
Yes.
So can you tell me what all we did?
We found out the gradient of the tangent, and
How?
then uh, because we had the radius and the tangent given, we
We had two
multiplied their,
points.
yeah,
We had the point that was on the circle and the point of the center.
yes.
With the help of this, what did we find out?
The gradient of the tangent.
First, we found the gradient of the radius.
Yeah.
Then, we found out the gradient of the tangent, inverse reciprocal.
Yeah.
Okay. After we got the gradient of the tangent, then what we do?
Then we plug in the values, the points.
We want the equation of the tangent.
Hmm.
How do we find the equation of the tangent?
We plug in the points.
We will use the slope point form equation.
Hmm. Okay.
What is the slope point form? Y minus y1 is equal to mx minus x1.
Yeah.
Okay. Which point will we take?
The one 10 0.
The one that is on the tangent.
Yeah.
So P is on the tangent, right?
Yes.
What is the coordinate of P?
10 0.
10 will become what now?
X1,
0 will become.
Y1.
How did we find the gradient?
We multiplied the gradient of the radius with the
Inverse
gradient
reciprocal of gradient of radius.
inverse. Yeah.
Inverse reciprocal gradient of radius.
Yeah.
Why inverse reciprocal gradient of radius?
Because we didn't have the gradient of the tangent given to us.
Because they both are perpendicular to each other.
Yeah.
Inverse reciprocal gradient of radius. Why? Because radius is perpendicular to the tangent.
Yeah.
Are you sure?
Yes.